11.2 Composition of trig and inverse trig functions. So here we will be looking at any time that we are multiplying a trig function on the outside of a parentheses against what would be on the inside of the parentheses, which will now be a different trig function. Now, in 11.1, we saw how we were multiplying against the inverse of the same trig. So we saw a sine, an inverse sine, cosine, inverse cosine, tangent, inverse tangent. Now we're going to see how the two trig functions can be different and how we would solve them. The first step to solving any type of equation that looks like a composition of trig function would be to start from the inside parentheses and work your way to the outside. That is the most important thing to do. That will give you some type of order towards leaning and getting towards that final answer. The next thing would be to keep in mind what the domain and range of each one of these compositions would be. Having that understanding that for sine, we would be going from -1 to +1, or the inverse of sine would be -π/2 to +π/2. All of that is extremely important as we work through each one of these compositions, because we could run into any one of our 6 trig functions. Let's go ahead and take a look at slide 3. In slide 3, we start off with our first question, which says, the inverse cosine of sine π/6. So the first thing we're going to do is we're going to have an understanding of where sine and π/6 would overlap. Now, the easiest way to work this problem out would be to go ahead and write out our table for our different functions. So we go ahead, we start off with our 30, 45, and 60, and we're working with sine, cosine, and tangent. Easiest way to start it off would be work with our 45s, which would be square root of 2 over 2, square root of 2 over 2, and tangent would be 1. For 30, we start off with 1/2, and 60, we would be going towards square root of 3 over 2. As we look at the cosine of that, those two variables, or those two values for the sine of 30 and sine of 60 would actually be flip-flopped, and we would see square root of 3 over 2, and we would see 1/2 take the 60 place. Last part would be taking a look at tangent of 30, which would be the square root of 3 over 3, and the square root of 3 for 60 would be that trig function value. So we're going to start off with understanding that 30 would be π/6, 45 would be π/4, and 60 would be π/3. So if we're taking a look at the sine of π/6, this value of π/6 would be equal to 1/2. We go ahead, keep it inside the parentheses, and we drop down the trig function on the outside, which would be an inverse cosine. As we're working our inverse cosine, the first thing that we have to understand is that the range for inverse cosine would go from 0 to pi. Our next step would be to go ahead and find where the inverse cosine would give us 1/2. So we go ahead, draw this out. our next step would be to figure out the exact placement of where this would go. We know that cosine would fall between quadrants 1 and 2, so it would not be within 3 and 4. So we would have cosine here and here. Cosine of 1 over 2 would be equal to pi over 3. So as we can see, the inverse cosine would give us pi over 3. Pi over 3 would fall right here within that first quadrant. Let's take a look at our next example. Notice here we're looking for the cosine of inverse tangent 1. So the first thing we're going to do is set up our graph. Now, the inverse tangent of 1 would give us a pi over 4. So let's talk about how we would come about this. The only time that we would have a value of 1 come out of this would be if, and only if, our numerator and denominator are equal to each other. Keep in mind, the tangent inverse, the range for it, would be negative pi over 2, comma, pi over 2. So we know that the two values would have to be equal to each other in order to give us a value of 1. Considering how this is a positive 1, there are only two places where this can occur. This would have to occur in the same location as our sine. Tangent would have to fall within quadrants 1 and 4. 45 angle would be the only one that would give us a possibility of us having 1 due to it being the square root of 2 over 2 divided by the square root of 2 over 2. And in this case, it doesn't matter whether we put sine on the top or the bottom. The fact that they are both positive and divided by each other, it will give us a positive 1. If we were in quadrant 4, notice one of those values, which would be the sine, would have to be negative, which means a positive divided by a negative would actually give us a negative 1. So we know that it has to be pi over 4. Let's take a look at our next position. Our next position would be the cosine of pi over 4. So let's take a look at what pi over 4 would be. And in this case, this would be the square root of 2 over 2, comma, square root of 2 over 2. Our final answer for this problem would be the x value, which would be square root of 2 over 2. Let's go ahead and take a look at our next problem. In slide 4, we go ahead and work the exact same style problems. We have a trig function on the outside. We have another trig function on the inside with a value of 1/2. Now in this case, we're looking for the exact value, but if we take a look, the inverse tangent is giving us a negative 1/2. Now we know that the specific values that we get from our table would not fall onto the 1/2. Let's go ahead, quickly write down our table just so that we can verify. Remember, we have 30, 45, and 60, sine, cosine, tangent. Square root of 2 over 2, square root of 2 over 2, and 1 within tangent. 1/2, square root of 3 over 2, square root of 3 over 2, 1/2, square root of 3 over 3, and square root of 3. Now, if we notice, for inverse tangent, there are none of the options within the 30, 45, 60 that would give us 1/2, or even the inverse of 1/2, which would be 2. In this case, the only way to be able to solve this problem would be by using our Pythagorean theorem. So we're going to first start off with understanding that the inverse of tangent would actually have a range of negative pi over 2 to pi over 2. Now, because this is tangent, remember this will have parentheses rather than brackets. So, first thing would be, let's go ahead and graph out where this would fall. So the inverse tangent is 1/2, which means this would be our sine over cosine. So 2 to the right and up 1. In this case, we are going to be in quadrant 1. So our cosine would be 2. Our sine would be 1. We would go ahead and complete the Pythagorean theorem. So we would have 1 squared plus 2 squared is equal to c squared. 1 plus 4 is equal to c squared. 5 is equal to c squared, which would give us the square root of 5 is equal to c. And that right there would be our hypotenuse. Now, once we have found the sine, or the tangent, inverse tangent of 1/2, which would be the sine of theta. Keep in mind, we know the sides, we are not sure of what actual theta is, our angle. Remember, our angle is right here. We're going to go ahead and find the sine of theta, which, remember, if we take a look at SOHCAHTOA, sine would be opposite over hypotenuse, which would give us a value of 1 over the square root of 5. Let's take a look at the next problem. Here we're going to begin with the cosine of sine inverse of negative 1/3. We'll first begin with taking a look at the range of inverse sine, which would be negative pi over 2 to pi over 2. In this case, it will have a bracket. Now, considering how we have a negative 1/3, we're going to go ahead and keep this in mind as far as where we would end up within our graph. In this case, we are going either 1 to the right and down 3. Correction. We're moving to the right, but we're either going to drop down 3 and our hypotenuse be 3, or it would be flipped to the other side. Since we know that sine would fall onto this right side, we know that our hypotenuse would have to be 3, and it would drop down by 1. We would then have to go ahead and find the missing side of our triangle. In this case, -1 squared plus b squared is equal to 3 squared. 1 plus b squared is equal to 9. B squared is equal to 8. B is equal to square root of 8. Once we found that side, we would go ahead and rewrite our phrase as the cosine of theta. Our cosine of theta would be the adjacent over the hypotenuse. Our adjacent would be the square root of 8 over 3. Let's take a look at our next problem. Here we have the tangent of inverse cosine of -1 over 3. Now in this problem, once again, we know that we're not going to end up with a 1/3 or a 3 over 1 for a cosine or an inverse cosine, which means we have to go ahead and find our location within our unit circle using our graph. First step, figure out our range for the inverse of cosine, which would go from 0 to pi. If we know that we're in between 0 and pi, just keep in mind where it would be that cosine would fall on our equation. It would fall on the top two. Notice from 0 to pi. We have a value of -1/3, which means for cosine, once again, SOHCAHTOA, we have adjacent and hypotenuse. The hypotenuse will always be a positive number, which means the adjacent would have to be the negative, which means we would be in quadrant 2. Our adjacent would be -1. Our theta would be in that corner, and our hypotenuse would be 3. We go ahead and solve for our missing side. In this case, -1 squared plus b squared is equal to 3 squared. 1 plus b squared is equal to 9. B squared is equal to 8. And b is equal to the square root of 8. Once we have found our theta, we need to find the tangent of theta. So we're going to go ahead and find the opposite, which is the square root of 8 over the adjacent, which is -1. This goes ahead and simplifies to a negative square root of 8 as our final answer. If you have any questions about this section, please feel free to reach out to me at any point.